Hello, so today we are going to take a look at this problem as part of Leetcode April challenge. So it's a shift 2D grid. So basically what the problem says is we have a 2D grid and an integer k, and we need to shift the grid k times. And what we mean by shift is doing these operations here. The element at ij moves to ij plus 1, so it moves to one column to the next column in the same row position, and then I n minus 1 moves to I plus 1, 0. So basically for the ones at the end, they come back circular. It's a circular shift in a way. And then m minus 1, n minus 1 moves to grid 0, 0. Okay. So you can see here 147 became in this column, 258 became in this column, and then 936. So one thing is that everything is just shifted by one column except the last column. It's a little bit unique. It's it seems like it's reversed and then became went to the first column. So that's what what happens here. Let's see if this is the same for this example. So for this example, 876 0 went, so 319 412, this one went here, this one went here, this one here, and then if we take a look at this, is it completely reversed? No, it's 13 at the beginning. It's not completely reversed because here it's not like 13 10 5 9. No, it's a little bit that 13 goes here, 10 goes at the end, and then 9 5 like that. So definitely the last one, which is 13, needs to go to the top, and then each one goes a row. The last one, each one at the end goes to I plus 1, changes rows by plus 1. Okay, so we have 13 up, 9 goes down, 5 goes down, and 10 goes down. So yeah, the first one goes to the top, and then the other ones just shift by one row. So that's kind of the idea here. It seems like what we are doing is for each column bigger than 0, shift by 1. And then for each so for each column bigger than 0, we shift by 1 column, and then for last column we have last cell moves to first cell in first row, first column, and then all other cells shift by one row. So this is what we are doing. So basically I think I can just do this by brute force. I will just need to keep track of the last column. So what that would mean is that, okay, let's open up item here, and then just have our grid. So I want to obtain the last column. So to do that, I think that's just this. Okay, so we can do last column. Okay, so we can do last column is equal to grid minus 1 to save it there, and now we can move stuff. So for I in range of length of the grid, actually this is what I obtained here is the row. I need to obtain the column, which is 258. So this is now last column. To get the last column, I think let's just do the simplest first. We can maybe like, okay, let's see, what if I do zip this? I think this should give me something good. 369, yeah, so 369 and then 258 and 147. Yes, so that gives me the column. So columns equal to this essentially. And now I can get last column is equal to columns -1. So once I do that, I get 369, which is the right value. And now what I can do is so I want to shift each column. So maybe we can construct this and then put it back. So if we basically have the zip grid and maybe call this G2 and zip it again, what will happen? Do we get the initial? Yes. Okay. So that's what I'm going to try to do here. So we are going to say columns, okay, and just say columns at position. I want to start from 1, right? Position I is going to be the previous column. Okay, except the last one, which is column 0, is going to be, we need to change it a little bit. So last column, what we need is, so last column processing changes. So basically to do that is, so here, then 0 columns. Now here, what we need is last cell, which is basically just last column -1. And we need to go through the column, so for I in a range of, so actually since this is column, let's do G. And now this is a row, so we want to go from 1 to the length of the last column. And what we want to do is say last column I is going to be equal to I plus 1, -1, okay? And last column in position 0 is going to be equal to position 0 is going to be equal to the first cell in the first column. So first cell here, that's going to be grid 0, 0. Going to be equal to the first cell, and then column 0 is going to be equal to last column. And then at the end we can return. I'm not sure if this tuple here would be bad. It's a tuple instead of a list. We can change that anyway. So columns. So, okay, why didn't zip? So this is for last column, columns -1. Okay, so if we do this, we get those. Now, what if when we do columns -1, that gives us those, so that should work. Okay, so it seems like maybe something to do with Python version. What if I change to Python? Oh, okay, deleted my code. Okay, let's see. Let's go to the applet here and see if it's something to do with. You don't have self, and then we can take. This is the grid. Okay, what is K for? Oh, okay. Yeah, I messed something up here because we need to shift actually K times. So we need to do this operation K times, and I'm doing it just once. So, yeah, I get the feeling that this is too complicated for what it should be. So we do shift, and then we do then at the end return grid. Okay, I wonder what column is here actually, so let's see. Okay, so it says zip object. We can just do list. First here. Okay, so now it's good. I would need to do something similar here. However, we have tuple does not support item assignment. Okay, because it's a tuple here. So what we need is actually we want to take this and change the tuple to a list. So let's say I have a grid. I say, okay, we want this. Now we can say X for X in, and we can turn this into a list. Okay, so this is what we want. This is what we want here as well, except this is columns. Okay, it seems like something is wrong with the last column for each one. So we move it to the next column. So that makes sense, but yeah, I think that, so this makes sense, but it seems like zip here is not happening at the end. Okay, so here we have k equal to 1. Let's try and see where the problem comes up. So here, if we print columns, and here, if we print same thing, so 1, 2, and then okay, so first we have one four seven 258 369. Okay, so this is the first one. Now once we shift them up, we should have something at least 147 in the middle and 258 at the end, but that's not what happened. We have 147 in both, so that's the problem there. So what I'm doing here is for each column I'm signing the previous one. Oh, okay, so the problem is that now the previous one has the value, so that doesn't work. Okay, it gets over. Okay, so how can we do it in a way that we don't, we need to start from the end. So if we start from the end like this, -1 all the way to 0, and we do -1. So with this column J, needs to be the previous one. Okay, so we put in each position. So for 0 we need to put, okay, so we need to stay at 0 so that it stops at 1. And now we have 147 here, 258 here, so that's good. And then the problem is with the last column, it's not changed properly. So for the last column, what we want is, so 147, 258, what we want is to end up with, so for the last column here, which is in our case 369, 369, so we want the last position, so we want 9 and then 36. But seems like here that's all messed up. We have 1 even there. So let's see for the last column here. So let's see first that we are getting the right last column. And then if we go here, let's see that we are getting the right last cell. And what else would be interesting? So here after changes, let's see. And then here I want to do 2 things to see what first cell is, and after setting up first cell, okay. Okay, so last column is 369, that's correct. Last cell is 9. After the shift though, so our shift here is wrong in the same way that what we had earlier is wrong. So what we actually need is to go from the back, -1. We want to reach -1, and we want to go 0, -1. Okay, let's see. So after the shift we have 336. However, the first cell was 1. Okay, so the problem is the first cell there, so okay, did I use last cell? Because that's what I want actually. I want the last cell, so not the first cell. Yeah. Okay, let's see. Okay, so this works now. Now let's just move this print for a minute. And let's run this. Okay, let's use more examples. Okay, looks good. Let me do one that is really like expensive, so maybe 20, 30 times. What's the limit for K? It seems like K can go up to 100, so let's just go all the way there. One thing I should be able to optimize that we can take a look at later is At some point, shifting will do the same thing. So optimize k. Maybe we can do k modulo something. But for now, let's submit this. Okay, so that passes. Okay, let's see if we can optimize this a little bit more. Yeah, I think we don't want to do it as many times as the length of the grid. We want to know how many columns actually. Okay, that doesn't work. So take k modulo vector that length. So it does seem like it was a reasonable thing to do. Okay, let's see what others did. So I'm just simulating the exact behavior here. Okay, so sounds like they do it m by n. I'm not sure why, but let's see. So this would be length of the grid, and then length of the first. Is grid guaranteed to be at least of length 1? Yes. So grid of 0. And we can do okay. Yeah, for some reason it doesn't look faster, but so since shifting right will put the last k cells in grid on the first k cells. We start from the kth. Okay, so let's check, for example, this solution. I think it's clever. So instead of doing the shifts by simulation, like transforming the grid for each shift, we just calculate the final position of each cell and go from there. So what I'm seeing here is that the new column position for a cell is whatever it was at before plus k, because we shift k times, so we shift the column k times, and then we took modulo n because when we reach the end we circle back to the front. Now for the row, every other column changes, it doesn't change except for the last, when a cell reaches the last column, then it shifts row by 1. And so what we do here is, when does a cell reach the last column? So it reaches the last column if it was as in the first column at the 0 position, then when we shift n times we reach the last column, and so that would be 0 plus n divided by n, that would be 1. From 1 to reach the last column, that's n minus 1 shifts. We need n minus 1 shifts. And so when we divide by n, we'll get how many times it shifts row. So if k, let's say if n is 3 and k is 6, then we will shift the first elements in the first column, we will shift them 2 times, we'll shift their rows 2 times. So that's the idea here. It's pretty clever. So let's try it out. So let's get rid of this. And so we will need, I prefer to call them rows and columns, and this would be the length of the grid and the length of the number of columns. Okay, so then we get the columns, and then next step would be to so we want to go through the rows, so that would mean we want to have our result, and the new position is going to be j plus, we want to shift by k, and we're going to do it modulo the number of columns, so with this. And for the rows, so maybe we can actually do it this way. So for the rows, we want the second one to be whatever was before, and then we shift by, should it be J2 or J? It's J, divided by n, or rows, and this would be our new index, and then we will assign I2, G2, sorry, this is res, we'll assign grid IJ, and here we need to construct it, so this is for in range of, so we have the rows here, and then we do this for each column. Maybe for can return res. Rows and then columns. Here we want to do modulo. Okay, if we use all examples. Yeah, so it seems like there is one test case here. Okay, should this be columns? I think. Okay, let's say we have something where rows are 2 and columns are 1, and then we do this. So the row's length is 2, that's good, and the column length is 1, so yeah, this is correct. What if even we do rows are 3? Okay. this is working. Now, why is it? Oh, okay, actually, it's plus that. Okay, and then the entire thing modulo rows. So this should be, when do we reach the last column? It's the number of columns, not the number of rows. Yeah. Okay, cool. Let's see the other examples. So yeah, we reach the last column if we, for example, for the first column is if we shift by a number of columns. Yes. Okay, so submit. Okay, so that passes. Yeah, this is an interesting approach where instead of doing the shift ourselves each time, we just compute the last position. That's all that matters. We don't need the intermediary grids. Yeah, so I think with these two solutions, that's good enough. Yeah, that's it. Thanks for watching and see you on the next one. Bye.